In this video, we're going to look at another applications of areas between curves. The question here is find the area of the region bounded by the parabolas y is equal to 4 minus x squared and y is equal to x squared plus 2x. Step 1. Find the intersection point of y is equal to 4 minus x squared and y is equal to x squared plus 2x. To find the intersection point, we let y equals y. And we solve for x. Y equals y. So let's do some algebra. We got 4 minus x squared is equal to x squared plus 2x. Let's bring everything to the left-hand side. We get minus x squared. We get minus 2x squared. Bring the 2x to the left-hand side. We get minus 2x plus 4 is equal to 0. Now let's factor out minus 2. We get minus 2 times x squared plus x minus 2 is equal to 0. Let's factorize this expression and solve for x. So we have x plus 2 times x minus 1. These are the factors, and make this equal to 0. And let's solve x plus 2 equals 0. That gives us the x coordinate of intersection. X equals minus 2. And x minus 1 equals 0. And we get x equals 1. We also need to know the y coordinates of intersection. Let's put x equals negative 2 into y is equal to 4 minus x squared. And that gives us y equals 4 minus 2 squared is 4. 4 minus 4, that's 0. So we get minus 2 and 0 as one of the points of intersection. And now let's put in x equals 1. Let's put it into, say, the other equation. Doesn't really matter which one you put it in because they're intersecting at that point. Y equals x squared plus 2x. And that gives us y is equal to 1 plus 2 equals 3. So the intersection point, the other intersection point is 1 and 3. All right, so step 2, sketch the bounded region y equals 4 minus x squared and y equals x squared plus 2x. So to sketch this, the best thing to do is to find the x and y intercepts of both of these parabolas. So we have y is equal to 4 minus x squared. This is a downwards pointing parabola because we have minus x squared. If you plug in x equals 0, you get y equals 4. This is the y-intercept. To find the x-intercept, let's make y equals 0. That means 4 minus x squared equals 0. We get x squared equals 4. Solve for x, and we get x equals 2, x equals minus 2, and of course y equals 0. Y equals 0. Now let's look at the other equation. Let's just make some room for ourselves. So let me erase some of this. And now for the second equation, y is equal to x squared plus 2x. This is equal to x times x plus 2. And x equals 0, x equals negative 2, if we make y equal to 0. And so we get x is 0, y is 0, x is negative 2, and y equals 0. And from before, we have x is equal to 0, y equals 4, and x equals plus or minus 2, and y is equal to 0. These are x and y intercepts of y equals 4 minus x squared. And these are x and y intercepts, x is 0, y is 0, and x is negative 2, y equals 0 for the other curve, the other parabola, y equals x squared plus 2x. So very easy to draw. We can easily draw that, and we already know the intersection points, which are at minus 2, 0 at this point, and also at 1, 3. So now let's set up a definite integral to find the area when x is between minus 2 and 1. Now the height of the rectangular element is defined by the difference of the top function, which is y is equal to 4 minus x squared, and the bottom function, which is y is equal to x squared plus 2x. So this is a top function right there. That's y top. And that's y equals 4 minus x squared. And this is y bottom. And y bottom is y is equal to x squared plus 2x. All right. So now let's define a differential area, dA. dA is going to be top minus bottom, the top function, which is 4 minus x squared, minus the bottom function, which is x squared plus 2x. Let's simplify that, and we get this height, 4 minus 2x squared minus 2x, which is the same as, let me rewrite this as 4 minus 2x squared minus 2x. So let's put this into a definite integral and integrate, and we'll find the area. So the area will be integral from minus 2 to 1 minus 2x squared. Let's rewrite it, minus 2x plus 4, and integrate this with respect to x. And this is a very easy integral to do. We just reverse the power rule. So we have area is equal to integral from minus 2 to 1 minus 2x squared minus 2x plus 4 dx. We're adding up all these vertical slices in the x direction and finding the total area. So area is going to be integrating term by term. We're going to get minus 2 x cubed over 3 minus 2 x squared over 2. And what is antiderivative of 4? Antiderivative of 4 is just 4x. Apply the fundamental theorem of calculus from negative 2 to 1. Putting the upper limit in, we get a is equal to, the area is minus 2/3 minus, the 2's cancel out, minus 1 plus 4 times minus 2, which is going to be, 4 times 1, which is 4, minus, now put the lower limit in, and we get minus 2/3. Minus 2 cubed is negative 8. Minus 2 squared is 4, minus 8. Let's simplify this. We get area is equal to, let's just expand everything. Minus 2/3, 4 minus 1 is plus 3. And then we have minus times minus is plus, times minus 3 minuses is negative. So we get minus 16 over 3. Minus 4 is plus 4. Minus 8 is plus 8. We're just distributing this minus sign here and here. All right, let's simplify this. Let's add the fractions first. We get minus 18 over 3. That's, of course, just 6. And look at the whole numbers. That's 3, 4, and 8. 3 and 4 is 7. 7 and 8 is 15. That's plus 15. So what we get is 15 minus 6, which is equal to 9. This is the area of the shaded region. This is this area here. This area is 9. This area. All right. Thank you.